Today we will be discussing about the axis of an ECG, that is how to determine the axis. We won't be going to the whole details and theory behind that. Our only aim is to master or to understand how to determine an axis of an ECG. So you might be very familiar with this picture, a very colorful picture. So even though it looks like a single circle, it's actually a three-dimensional picture. Okay, so you can see that there is a horizontal line which divides it into a lower half and an upper half. The lower half represents the positive semicircle, the upper half represents the negative semicircle. Okay, you can see it is 0 degree, it is plus 60, it is plus 90, it is plus 120 and plus 180. While in the upper half it is minus 30, minus 90 and minus 150. And you can also see how the various leads are oriented three-dimensionally. Okay, that is the lead 1 is at 0 degree, AVL minus 30, AVR minus 150, lead 3 plus 120, AVS plus 90 and lead 2 at plus 60 degree. And in addition to that, there is a pictorial representation that shows different axes. So you can see this pink area. This pink area is the normal axis of an ECG. That is, it ranges from minus 30 degree to minus 90 degree. Okay, you can see this green area represents where the ECG axis lies in case of a left axis deviation. That is from minus 30 degree to minus 90 degree. And this bluish area represents the right axis. That is, it lies between plus 90 to plus 180 degree. And you can see this is the yellow area. So this yellow area is called an extreme axis deviation or an indeterminate axis, and the range ranges from minus 90 to 180 degrees. So this is how that is what we should understand basically from this picture. I know it's a bit difficult to remember all these things, so we are forgetting everything. Just forget everything. What we only need to know is about the lead 1 and AVF. We are only worried about the lead 1 and AVF. So coming to the discussion, so we are discussing how to determine the axis. Okay, so assume this is the circle, this is the horizontal line, this is the vertical line, lead V1 and AVF. We only need lead V1 and AVF to determine the axis. Okay, we know that lead V1 is at 0 degree, the AVF it is plus 90 degree. Okay, so if you look at an ECG, you can see that normally the lead V1 looks like this. That is, it has got a positive QRS. Also, the lead AVF also looks like this. That is, it also has got a positive QRS complex. Okay, so just looking into the direction of the QRS complex, we will be able to determine the axis of an ECG. Clear? Okay, so this is, so you are looking to an ECG and you found that the direction of the lead 1 is similar to this, that is positive, and the direction of lead AVF is also positive, that is, this is the direction of lead 1, this is the direction of AVF. So that means the axis of an ECG lies in this quadrant, that is, it has got a normal axis. Okay, so assume in another ECG the lead 1 is like this, the same as before, that is, the direction remains the same, but the lead AVF has got a QRS which is in the opposite direction, that is, it is like this. QRS is in the opposite direction. That means the direction of the vector has changed to here. Now the AVF is not at all this, but the AVF is, this is the AVF. So where the axis will lie? The axis will lie here. That is, we know that this is the position of lex axis deviation. Okay, assume another ECG where the direction of the AVF is this, that is, the direction of AVF has changed. So that means it is not at all the percent AVF, instead the percent 1. So instead this will be the lead 1, but the AVF remains as the same. AVF remains as the same, that is the same positive QRS. So the AVF axis is, the direction is this, but the lead one direction has changed. That means the axis lies here, that is it has a at right axis deviation. Okay, assume the last case where the lead one is negative, that is negative means this direction, and the lead AVF is also negative, that is this direction, so that the axis will lie here. That is, from the previous picture we know that it is the extreme axis. This is the extreme axis of the indeterminate axis. That is how the different axis comes. Okay, I hope it is very clear. So coming to the discussion, it will be more clear. Okay, so that in this picture you can see that lead one is he coming to this quadrant. Lead one is positive, lead AVF is negative, so that lead one direction is this, while lead AVF direction is this, so that it is left axis deviation. Okay, then coming to the next picture, lead one is positive, that is this, lead AVF is also positive, that is this, so that it has got a normal axis. Okay, so coming to the next picture, lead one is negative, so that the direction of lead one is this, and the lead AVF is negative, so that this is the direction, so this is the axis, that is the right axis deviation. And coming to the next picture, you can see that the lead one is negative, so that the direction will become this, the lead AVF is negative, also negative, so the direction comes this, so that it has got an extreme axis or an indeterminate axis. Okay, this diagram explains the same thing. By looking into this, it will be very clear also. Okay, so we will be discussing some real examples. So in this you can see that here the lead one is positive. Okay, the lead AVF is positive, so that what is the axis? Normal. Okay, here the lead one is positive, the lead AVF is negative, so what is the axis? So that it is left axis. Then comes, so here the lead one is negative and the lead AVF is positive, so what is the axis? It is right. Then coming to the next, here the lead one is negative as well as the lead AVF is negative, that is it is extreme axis or indeterminate axis. So what is this? This is a wide complex tachycardia, that is VT always it has got an indeterminate axis. I hope it's very clear. Thank you for your patient listening. Please subscribe and share to your friends. I hope it will be very useful. Thank you for the patient listening. Thank you guys.